Security is an issue. There's a new FBI building in Chicago that was built using precast concrete, and the U.S. Air Force is doing some blast-resistant design testing with precast. So we are seeing more and more people looking for ways of building secure buildings, whether it be for floods or hurricanes or attack. Early consultation is a trend that my members really like to see. They're starting to get involved in projects, usually in the schematic design phase is when they like to get involved, when they can talk to the architect and say, yes, this will make a good precast project, or no, it's not an ideal project for precast. This is Soldier Field, and it really represents the speed of design and construction in a lot of ways, and the teamwork that people are looking for on some of these bigger projects. It was pretty interesting to erect because you could only erect it from inside the bowl of the field. You couldn't do anything from around. There was a roadside on one area, and then there were parking decks on either side. So they really were limited. So the cranes were quite challenging on this project. The precaster worked with the team and came up with some solutions for some lightweight concrete on some of the larger pieces of the precast on the top of the bowl, because the crane just wasn't able to have that reach with some of the heavier pieces of concrete. They also had to do some finagling with the steel erectors. The steel erectors actually came in, used the cranes during the daylight hours, so from 6 a.m. to 6 p.m. the steel erectors came in, and then the precast erectors came in, and I don't know how they drew the short end of the stick, but they got to erect precast all night. So they actually had 24-hour erection going on in the project. So, you know, typically this would have been a 24-month schedule with the parking decks and the stadium, but because of the Bears playing schedule, they had to finish it in 18 months, and they did it. The contractor would have been fined, I guess, $5 million for any games that the Bears were going to miss at the stadium. So they had real incentive to get it done on time. The other portions of this that were precast were the parking decks, and they're pretty interesting parking decks as well, because they've got large planters on the top of it that actually have trees inside the planters, and then part of the parking deck is underground, so the loads and the Soldier Field rests on top of one of the parking decks too, so the loads that they were taking were not typical parking deck loads, and it was a pretty interesting project. So they were originally designed as cast in place, but cast in place couldn't meet the design schedule or the construction schedule. So it was a pretty interesting project as far as the speed of construction and the way that the group had to really function as a team to get it done in time. Just a little bit about finishes and colors. There are a lot of possibilities out there when you're talking about architectural precast and how are you going to finish a building and what is it going to look like. One of the things that you'll see at the architectural plant is that you can finish the surface of a precast product in different ways and get very different looks. This is actually an example of just a 12-inch by 12-inch sample of concrete, and it's been finished in 3 different ways. On the far side is an acid etch finish, and that uses muriatic acid and a hot water wash, and it just removes the finest particles of the concrete to give you kind of a smooth limestone-like finish. In the center, they've sandblasted it, so you get that kind of white halo effect, and they've also gone a little bit deeper so you can see more of the aggregate. In the section here, you've got a chemical retarder that's actually a sugar-based retarder that stops the concrete from curing on the surface. So you stop the concrete from curing, you then use a high-pressure water wash, and you can expose a lot of the aggregate that way. So you really can get very different looks. It's all the exact same mix of concrete. What they've changed is the way they've finished it. Yes, and it's all going to vary on the project and how many pieces you're finishing that way, and the sizes of the panels and how many panels you have to move in the yard and things like that. But also, you know, some of the precasters do more acid etching than sandblasting, and those really cost about the same. Chemical retarders can cost a little bit more than those. Yeah?
Do you wait till it dries all the way before you do that?
Typically, yeah, you'll do it. You'll cure it overnight, take it out. It might sit in the yard for a day or two, and then they'll go ahead and finish it that way. So it's not like they're waiting weeks and weeks, but sometimes they'll let it cure a couple days. Any other questions? One of the things that we've seen a lot of lately are these insulated wall panels where they're adding insulation, and you can see this is a Dow system where they've got these connectors that are done out of a composite material. Sometimes you'll also see connectors done out of steel, but those will carry the cold temperature through. So a lot of the people who are really concerned about the thermal mass and not having cold spots in a wall panel will use something more like this. It is possible now to have insulation from top to bottom and side to side in a project. Precast connections. Just talk about when you're connecting wall panels, you really are going to have two basic types of connections. One is your gravity connector, and that's going to be what defies gravity and holds it up on the wall. Gravity connectors you're going to have at least one. You might have two, but you'll never have more than two because you can't predict the loads if you have more than two. So those are going to be on the wall panel where they need to connect to the structure. So it's going to change in every wall panel. The gravity connectors will be in a different place. Then the wall panels will also have tie-back connections. And the tie-back connections, you're always going to have a minimum of 4 connections, and then sometimes you'll also have 6 connections. I need a brighter location, but you've got them located on the corners here. And then if you have a long panel, you'll also have them located mid-span. So the structure of the building needs to have a place where those tie-back connections can actually connect or tie back to the building. This just shows you again in a building where are all the connections going to be for it. You've got your cast in place slab on grade in the bottom, and then you've got wall panels, and then if you look kind of behind it, you can see where all of the connections are with your gravity connectors, your mid-span connectors, your floor connectors, and that's on a steel piece. And there it is again. You can see all of the framing. This is with steel framing. Then if you've got like a wall panel, you're also going to have it connect back. A lot of times you'll have some kind of shim or some kind of composite material that the connections are actually going to rest on, so you don't have steel resting on steel. The weld plates are going to be cast right into the precast panels, and so the precaster was going to have working drawings in the plant that really shows the guys where all of the steel needs to go, where those connection panels go, and then you can connect it to a steel building, a cast-in-place building, or a precast building, and those other the partners to those steel plates or the connection plates have to be ready on the building where you need them. Just another panel to beam connection system where you've got the panels, or the pieces embedded right into the precast and then bolted on. Then sometimes you'll also have a panel-to-panel connection to keep there from being too much movement in between the panels, and those are usually done with a threaded insert. Typically you are going to have a joint in between the panels that'll be caulked on those wall panel projects with either a single line or double line of caulk.